Have you ever wondered how your computer knows exactly where to send data on a network? Like how your Wi-Fi router talks to your phone and not the TV next to you? That's where MAC addresses come in. They're like digital name tags that help devices identify each other on a local network. In this video, we're breaking down what a MAC address is, how it works, and how its structure reveals more than you might think. Let's get into it. A MAC address, short for Media Access Control Address, is a unique identifier assigned to a network interface card, or NIC. Think of it like a serial number burned into the hardware that helps devices recognize each other on a local network. Every device that connects to a network like your laptop, smartphone, printer, or smart fridge has at least one MAC address. It's what lets the switch or router say send data to that device, not the other one. MAC addresses are used on layer 2 of the OSI model, the data link layer, and they play a critical role in local area network communication. When your device sends a data packet on a LAN, it uses MAC addresses to make sure the data goes to the right place. Here's how it works. Let's say your computer wants to send something to your printer. It wraps the data up in a frame that includes the printer's MAC address as the destination address, and the MAC address of your computer as the source. That way when the frame hits the switch knows exactly what port to send it out of. Routers generally replace the MAC address when data goes to another network. The MAC addresses are mostly used for inside your local network and not across the internet. A MAC address is typically written as 6 pairs of hexadecimal digits, and that's a base 16 numbering system ranging from 0 to 9 and A to F. An example of a MAC address could be something like 00:1A:2B:3C:4D:5E. It's a mouthful to actually read off a full MAC address. Regardless, the first half being the first 3 bytes or 24 bits is called the Organizationally Unique Identifier, or OUI for short. This identifies the manufacturer of the network interface card. So if you see a MAC address starting with 00:1A:2B, and that OUI is registered to someone like Cisco, you know that device was built by them. Now the second half, or the last 3 bytes, is assigned to the manufacturer and is meant to be unique and specific to that device. And together, these two halves create a globally unique address, or at least in theory. Now while MAC addresses are supposed to be permanent and unique, they can sometimes be spoofed, meaning an attacker can change their MAC address to pretend to be another device. And this can be done for several reasons. For starters, it can be used to evade network restrictions that block or allow traffic based on MAC addresses, essentially bypassing access controls like MAC address filtering on SOHO routers. This can also be used to launch an attack by impersonating trusted devices on a network. And since MAC addresses operate at the data link layer, many network defenses won't notice they're being spoofed. And that's why MAC-based filtering or identification should never be your only defense. While it's useful, it's easy to defeat. So that's what a MAC address is. It's a unique hardware-level identifier used to route data within a local network. It's not just a random string of letters and numbers. It's a structured identifier that tells us who made the device and ensures data gets to where it needs to go. But as we've seen, MAC addresses can also be spoofed, so they shouldn't be relied on for authentication or device trust on their own. If you enjoyed this video, please consider liking the video or check out one of the other videos on screen. Thank you so much for watching, and I'll see you in the next one. Take care.